So I think y'all's copy starts with like vocabulary. We're not doing vocabulary. Go to the back of the first page. So just a reminder of how the formula works if you're doing it by hand. I don't have anything to do by hand, but this formula is on your test in your multiple choice part. Okay, so it is in your multiple choice part how you set it up. Everybody okay? All right, so you do need to know that formula and how you set it up. Remember, it is like 10 choose 4, and then your probability of success, and how many times you're going to choose that success, and then your failures, and then how many failures you're going to have. Okay, so you do need to know that formula for yep. Hold on. Emily, I don't have your chapter 5 test because your dad took it to you. So I can't even send it to you. Yes, no, maybe. Sorry. All right. Sorry. Sorry, y'all. Okay. So one more time. This is like one of the first few questions that you get on your multiple choice. It's just how you set it up, and that's it. It gives you all the information you need and just asks you, how you set it up. So then recall that there are 4 suits, spades, hearts, clubs, and diamonds in a standard deck of playing cards. Suppose you play a game in which you draw a card, record the suit, replace it, shuffle, and repeat until you have observed 10 cards. Define X equals the number of hearts observed. Show that X is a binomial random variable. How do we show that it's a binomial random variable? Bins. Okay. So what is the B for? It stands for binary to show that it has 2 parts, a success and a failure. What's your success? A heart. What's your failure? Good. What is I? What does independent mean?
One outcome doesn't affect another outcome.
Is that the case in this one? Yes, because they replace it. What if they weren't replacing it? What would we do? It would not be independent, so what would we do? Check the 10% rule. What is that?
What was if it's less than 10% of the population, so is the population do 52 or 52 cards in it?
Yes. So if it's less than 10% of the population, we can move on and assume that it is independent, right? Is everybody good? So that can take that out. All right, what's your N? The number of observations, or 10. And then what's your X?
13 out of 50.
Your probability of success. What is that? Which is 1/4 or 0.25. Doesn't matter which one you give, okay? It does not matter.
I'm kind of confused.
What part?
How you got 13?
How many hearts are in a deck?
Oh, okay. So that's just
You just have to know it. 13 out of 52. Any questions on the first part? Okay. Next. Find the probability of observing fewer than 4 hearts in this game. What I would suggest is that you always write the probability statement. So the probability that X is what? Less than 4. I don't need to see it worked out. If you don't want to, you can. If you want to, I don't care. Like, you don't have to write it out by hand. you can do on your calculator, but make sure you write that stuff out. If you just give me the value, I'm going to count half credit off. Does that make sense? All right, so how would you do this one?
CDF.
Okay. Mhm. What am I going to put in?
Your title is Kim.
Put it on my paper. Hold on.
Your number you put in would be,
What comes next then?
I'll probably.
P. What is P? And I put in 0.25. Doesn't matter. You can put in 1/4. You can put in 13 out of 52. All of those will work. So don't stress out about which one you put in. It doesn't matter. And then what's the number you put in? Why 3? It says less than 4. Good. What if it would have said greater than? What do I got to make sure I do?
1 minus.
1 minus, and then we'll talk about that when we get there, okay? So we put that into our calculator and we get 0.7758. Good. All right. Any questions on that one? Everybody okay? All right, same thing on the next one. Show that X is approximately a binomial random variable. So suppose 72% of students in the US would give their teachers a positive rating if asked to score their effectiveness. A survey is conducted in which 500 students are randomly selected and asked to rate their teachers. Let X equal the number of students in the sample who would give their teachers a positive rating. So again, how do we show that they're a binomial random variable? Okay. What's your success? Positive rating. What's your fail? A negative rating. Is this independent? Think about it. If you're given a survey, do you give that person a survey and then put them back in the deck? Yes or no?
No.
No. So what do I need to do here? Again, because we're giving them a survey, we're not going to put them back into the count. We're pulling them out each time, just like the pilots. We're pulling them out. We're not putting them back in.
Do we have to put not replacing, or can we just write no?
I put not replacing to get you to understand. You can put no and then do the 10% rule, but you do have to do the 10% rule if you put no. Okay.
Okay.
So 10 times 500, and all you have to do is put that is less than the population. And that's what you're checking. You don't have to put any more than that, okay? So that tells me that I can keep moving on, that I can still use the binomial CDF for PDF. All right, what's your N? And what's your probability of success? 0.72, perfect. All right, any questions on that one? Everybody good with bins? Watch that replacement and not replacement, okay? So this one says use a normal approximation to find the probability that 400 or more students would give their teacher a positive rating in this sample. So to do normal CDF or PDF, I'll figure out what that is in just a minute. What are the things that I need for like my calculator? So if I decide, what am I going to do? I'm going to do normal. This one, I want the probability that, how do I write this? 400 or more students. Greater than or equal to 400. What are the things that I need for normal CDF? What else do I need? What are all the things that I need right here? Good. So I need to find these two because I don't have them. So how do I calculate, sorry, my mean and my standard deviation. Uh-huh. Very good. My mean is NP. My standard deviation is the square root of NP 1 minus P. Very good. Ooh, I did teach you. Good job.
I think this is the stuff I've gotten last.
Well, good, because the next chapter is going to make big, long stuff dealing with this. It gets worse. You know, those state plan do concludes. You know, the state plan do concludes. It's all repetitive. So what you're going to end up doing is you're going to state something, and then the way you plan it is you're going to go through bins and use the 10% rule, and then you're going to find out that it's binomial, and then you're going to check the large counts, and then you're going to make it normal, and then you're going to do normal, and then you're going to conclude. Yeah. It's going to be all one problem instead of being separate. Yep. Mhm. All right. So what was your N? 500. What was your P? 0.72. This gives you 360. Again, square root, your N was 500. Your P was 0.72. That makes your 1 minus P what? Good. Which gives you 10.04. Normal CDF. What's your lower? What's your upper? So we just used 10,000. We found out our mean was 360. Our standard deviation was 10.04. And then don't freak out when you get a crazy number. When you guys put this in here, you're going to get 3.38 e to the negative 5. Realize it's 400 out of 500. That's a lot, right? 400 out of 500. So that is 0.40338. So it's a very small percentage.
Can we leave it as the e to the negative 5?
I would not.
Okay.
So with that.
I don't think it makes a difference. I'm sorry. I don't think it makes a difference, but I just would not.
What do you do, like, if you write it outside of time presentation, is it like one less?
Yeah, it's always one less. Mhm. All right, so then the next thing we're going to work on is geometric. What's the difference between binomial and geometric?
Geometric don't have a defined set of trials.
Yep, no fixed set of trials. So know the difference between geometric and binomial. And you guys can still do bins with geometric. Just the difference is when you get to the end, there's no fixed set. So if it asks you about that, that's what you're going to do as well. So when we get to this first part, you need to know this formula. Okay. So they might ask you that in your multiple choice as well. Now we're going to do that formula within these little problems down here. Sometimes it's easier just to go ahead and do that formula than it is to put it in your calculator. Just depends on what the numbers are, okay? All right, so suppose 20% of Super Crunch cereal boxes contain a secret decoder ring. Let X equal the number of boxes of Super Crunch that must be opened until a ring is found. So show that X is a geometric random variable. So you can still use bins because what is the difference between the binomial and the geometric? Just the end part, right? Just the end part. So what's the B part? So that's what we're going to do. I'm just not going to list out the word bins, okay? So you have a success of having what? Find a ring. You have a failure. Okay. What comes next? It's independent. One box doesn't depend on the other. Okay. The next part is the N. What do we know? So we search until we find. And then what else? What is the probability? Yep, and that will stay the same as well. So they all have the same probability. The only difference is the set number of trials. So find the probability that you'll have to open 7 boxes to find the ring. So the probability that X equals 7. So I'm going to do it by hand and I'm going to do it in the calculator. I'll show you both. And again, sometimes it's easier just to go ahead and do it by hand than it is in the calculator, okay? So by hand, the probability that X equals 7 is that we're going to fail 6 times and succeed on the last time. So that's what it looks like by hand. In the calculator, we're going to do GMF, which one? PDF, because we're looking for exactly 7 or perfect 7. You put your P in first, which is 0.2, and then your X value, which is 7. Both of those give you the same value of 0.0524. Again, I don't care which one you do, just make sure you define both.
How do you know, like, to use geometric?
Because we defined that it was geometric because we want to open it until a ring is found.
Okay.
If it says do 6 trials, we know to use binomial. Everybody good? All right, check your next one. Find the probability that it will take fewer than 4 boxes to find the ring. So how do I set this up? What's my probability statement look like? Is it just less than? Just less than. Because it says fewer than 4. All right. So on this one, I would do my calculator only because I'm a little bit lazy and I don't want to I don't want to think too much about it. Okay. So I would do Geo, which one? CDF, because it's not perfect. And then I'm going to do my probability is still what? 0.2. And my X value is going to be 3. It's not equal to 4, so I'm not using 4. Okay. This will give me 0.488. How many boxes would you expect to have to open to find a ring? So this is one we haven't really done. You might have done it in your homework. This is your expected value. We talked about it real briefly in our notes.
That's the mean, right?
Mm-hmm. Remember that is 1 over P. So you may have to do this in your test.
We definitely have those like this in our homework.
Okay.
Our training ones.
I don't know, like, I went over your free response and I don't remember seeing it on your free response at all, but it could be in your, multiple choice, but I don't think this is on there at all, but just in case. And then what is your P value? Which is going to be 5. So these are pretty cut and dry, and there's literally only like 9 things that you guys have to remember. And I'm just going to slide down to the bottom here and just write down what I saw when I went through it. There are a couple questions in your free response that you're going to be like, I'm not sure how to write this. And basically what it's asking is, if they go with a different company or they need to do this, is it going to change anything? it's not a big deal. You're just asking, it's just asking you what you think. If it's close to the same, going with a different company is not going to change it. If it's something that's a lot different, then yes, it will change it. So just check those out. I'm just basically looking at your answers. They're probably not going to count against you at all, so don't stress about those. I'm just looking at the ones that you're actually doing work on. Okay? Does that make sense? So don't stress about those, just write something. All right? So the first thing that you need to know is the binomial formula by hand, and I've already told you that. And again, that's more for the multiple choice than it is to actually do the work. When you get to your free response, you can do it however you want to. But I know that there's a multiple choice that says, how do you set it up? Okay. You need to know the difference between binomial and geometric. And they're going to ask you questions like, how do you know that this is geometric? How do you know that this is not geometric? How do you know that this is binomial? How do you know this is not binomial? Stuff like that. So just read carefully, read carefully. You need to know how to find the mean and standard deviation. You guys did great on that. I think that's on there a bunch of times. A bunch of times. And that's within multiple choice and free response. The NP and the square root NP 1 minus P. So y'all had that, so y'all are fine. Don't know what that means. I might have to look that up in just a second. All right, number 4. Remember that if you have the probability like this, something like this, that x is greater than 6, you're going to do 1 minus the probability that x is less than or equal to 6. But if you have the probability that x is greater than or equal to 6, so the difference is this one is not equal to and this one is, you're going to do 1 minus the probability that x is less than or equal to 5. So watch that. You know that geometric is a not set number of trials. Both have consistent probabilities. So when this comes in, there's one that asks about what makes it geometric or something. And it said something about not having a consistent probability. Geometric has to have a consistent probability, okay? Know the geometric formula by hand. And both of those are on this sheet. So just so y'all know, because I know y'all didn't have, you have it here, but so 1 minus P to the K minus 1 times P. So failures to the number of times you're going to fail times the probability of success. The binomial formula, I'm going to go back up and do that real fast. Real fast. Was N choose K. I want to make sure I get it right. All these letters. N choose K. It was right here. I told y'all to mark that one. PK and 1 minus P to the N minus K. Sometimes I do it backwards. I just wanted it to match whatever the sheet had, so you got it consistent. And then let me look and see. Oh, sorry. Let me look and see what I wrote this for. I just wrote that geometric and binomial need replacement because the probability of success has to be the same. So I think you just need to watch that replacement, like on the sheet that I told you when you did geometric, how you can do bins, but make sure that if you're doing replacement, like the survey, make sure that you check that 10% rule. So if there's a multiple choice that says, I think there's a question. I think it's this one.
What else is there about the number?
You really don't yet. You don't.
I just don't-
It's gonna come up in a few. So what does the large counts tell you? Do y'all remember? Large counts tells you that you can move it to normal.
Well, how do you know if it's large?
You do the NP and the N1 minus P. But we're not doing that yet. They just introduced it.
Are we gonna go back there?
Yes. Remember I told you they're gonna go through a long list of stuff that you're gonna have to do. So right now it's just
But we're
focused
not
on,
just gonna jump right into anything, like, they're not gonna go in.
yeah. So that's pretty much it. I think you'll be okay. I don't think you have to stress about it too much. If y'all have any questions, I'm gonna stop sharing. If y'all have any questions tomorrow, please let me know. Email me, remind, whatever. I don't care. Just let me know when you get stuck. If you're sitting in class asking questions, Rachel, don't freak out. Ask me questions.
So I'm a little confused.
What are you confused about?
What you wrote on number four, I'm just like, that's what confuses me.
Okay.
I'm
So
starting to mess up.
why are you gonna mess up on that? So on this, on this part, if you, Zoomers, if you want to go, you're good to go. You don't have to be in here. So on this one, if it's greater than six, we're gonna, hold on, let me go to this one. Okay. Greater than or equal to six, we're gonna include six and everything bigger than six. So we're gonna cut out anything less than that. So like if I draw it, 0, 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. I want everything greater than or equal to 6. That means I want all of this. So I'm gonna cut 5 and lower. Okay, if I go to this and I draw it 1, 2, 3, 4, 5, 6, 7, 8, I want everything greater than 6, not 6. So I gotta cut 6 and lower. Visually, can you see that a little bit better?
Yeah, it makes more sense now.
That's what you gotta do.
Okay.
Sometimes seeing it makes it better for
Yeah, it
me.
makes it's when you write out, what in the world. That
Yeah.
makes a lot of sense.
I have to write it a lot of times.
Thank you.
You're welcome. Everybody else okay? Anybody else have any questions?